Have you ever opened a toolbox, grabbed a screw, and thought, why on earth do I need 5 different screwdrivers for this? You've got the familiar flathead, the Phillips, maybe a square-shaped Robertson, a star-shaped Torx, and then some strange little screw that seems specifically designed to ruin your afternoon. But these different screw heads aren't random. Each one was developed to solve a particular problem, whether that meant transferring more torque, preventing the driver from slipping, speeding up factory assembly, or making a screw harder to remove. So why did we end up with so many designs in the first place? To understand that, we have to go back to when the humble screw was still a relatively simple piece of hardware, right here on History of Simple Things. For a long time, the most basic screwdriver was simply a slot cut across the top of the screw. It was easy to manufacture and easy to use with a flat-bladed screwdriver, but it had an obvious weakness. The screwdriver could easily slide sideways or climb out of the slot when significant force was applied. As manufacturing became more mechanized in the late 19th and early 20th centuries, that became a bigger problem. Factories needed workers and machines to install thousands of screws quickly and consistently. This encouraged inventors to experiment with shapes that could better connect the driver to the fastener. One important breakthrough came from Canadian inventor P.L. Robertson. His square drive screw became commercially successful around 1908 and offered a much more secure connection between screw and driver. A few decades later, Henry F. Phillips developed the cruciform drive that carries his name, with patents granted in the 1930s. And from there, the screwhead family tree kept growing. Let's start with the simplest, the slotted screw. Its design is almost hilariously straightforward. There's just one straight groove across the head, and the screwdriver fits into it. That simplicity is actually its biggest advantage. The recess is inexpensive to manufacture, and the tool itself is easy to make. The problem is torque. Push too hard while turning, and the driver can slip right out of the slot. This is especially annoying with power tools, where the screwdriver can suddenly skate across the surface of the screw, or worse, across whatever you're trying to build. Still, flathead screws haven't disappeared. They remain useful where low-cost manufacturing, traditional appearance, or simple hand installation matters. Then there's the Phillips screw, probably the most recognizable screw head in American homes. Instead of one slot, it has 2 intersecting slots forming a cross. This gives the driver a central position and makes it easier to align with the screw. More importantly, it was well suited to powered assembly. Interestingly, Phillips wasn't designed to eliminate slipping completely. Its geometry allowed the driver to cam out, meaning the bit could climb out of the recess when enough torque was applied. In early manufacturing, this could help prevent screws from being driven excessively tight when torque control technology wasn't as advanced. Today, that same characteristic can be incredibly frustrating. If you've ever heard a drill make that horrible rrrr click sound while destroying a Phillips screw, you've experienced cam out firsthand. Now consider the Robertson or square drive screw. Instead of a cross, the recess is a square. The shape allows the driver to sit securely inside the screw and makes it much less likely to slip out during installation. Robertson's commercially successful design dates to 1908, and its manufacturing method helped make the square recess practical to produce at scale. One particularly useful feature is that a Robertson driver can hold the screw on the end of the bit. That makes it convenient when you're working with one hand or driving screws overhead. It became especially popular in Canada, where square drive screws remain common. Then we get to the star-shaped Torx drive. Torx uses 6 rounded lobes rather than the sharp corners of a Phillips or square drive. The geometry allows the driving force to be distributed effectively across the contact surfaces, making it much more resistant to cam-out and suitable for higher torque applications. Torx was developed by Camcar Textron in 1967 and became especially useful in automotive, electronics, and industrial applications. If you've ever wondered why modern cars, machinery, bicycles, and electronics seem to contain mysterious star-shaped screws, this is why. The design works particularly well with powered tools and repeated assembly. Hex socket screws take another approach. Instead of a protruding hexagonal bolt head, the hexagon is recessed into the screw. You insert an Allen key or hex bit into the socket and turn it. This design can provide strong torque transfer while keeping the overall head compact. Hex socket fasteners became commercially practical in the early 20th century, with William G. Allen associated with early patents and production of hex socket screws around 1909 to 1910. You'll find them everywhere from machinery and bicycles to furniture and automotive components. So, why not just pick one? Because no single screw head is perfect for every job. A flathead is cheap and simple. Phillips became extremely useful for mass production. Robertson offers excellent bit engagement and convenient handling. Hex sockets provide compact, strong connections. Torx handles high torque, while reducing the tendency to cam out. And there are even more specialized designs, including security versions with pins or unusual recesses intended to discourage tampering. So the next time you stare at a screw and wonder why its head looks completely different from the one beside it, remember, that strange shape is basically a tiny piece of engineering history. Every groove, corner, and curve exists because someone somewhere had a problem with the previous design and decided there had to be a better way. And sometimes that better way is exactly what saves you from stripping the screw you were supposed to remove in 5 minutes. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.